All right, so I had to start a new video to finish this up. So we are on page 33, and we are going to be looking at just the top 3 problems. And so I didn't realize that my video wasn't working, so I did get started on this problem. And the first step I did is I did make sure it was in standard form and it equaled 0, so we're good there. And then from there, what I'm going to do is look for a GCF. So that's what I did, is I noticed that I could factor a 2 out of each term. And when I factor a 2 out of here, I'm left with x squared. And when I factor the 2 out of here, I'm left with minus 4. And then from there, it was a difference of squares because of the difference, the subtraction sign. And this has a perfect square, or this is a perfect square, so it has a square root of x. And 4 has a perfect square, or it is a perfect square, it has a square root of 2. So this 2 will jot down my GCF, and then in parentheses, I'll do an x plus 2 and an x minus 2. And again, now that I'm ready to solve, I'll set my factors equal to 0. So I'll set this one equal to 0, this one equal to 0, and I can set this one equal to 0, but what's going to happen is 2 will never become 0. So this isn't one that I would worry about solving. I'll only worry about the factors that have an x, because there is a certain number is going to go in and make this factor worth 0, where this is always just going to be worth 2. So here, my one step to solve for x is subtract 2, so I get negative 2. And here, my one step is to add 2, so I get 2 and negative 2. And reminder, you can always write your answers like this, which is a good idea to start doing, because we're going to see this format pop up very soon. So on my next problem, again, I'm going to look for a GCF. So somebody in one of my classes asked, well, what if you didn't do the GCF? If you didn't do the GCF here, you wouldn't see the difference of squares. So that's why the GCF is really important. If you didn't do the GCF here, the only thing that would happen is the numbers in your x would be bigger. You could still do the problem, but it's nicer to work with smaller numbers. So we just kind of get in this habit of always looking for a GCF. All right? So in this problem, the number I notice that I can take out from everything is a 2. So when I do that, I'm left with 4x squared here. When I factor out a 2 here, I'm left with 2x and 5. And so now, based on this, with 3 terms, I'm going to make my x, so I need factors of 20 that get you to 12. And those are going to be a 10 and a 2. So this 2 is just dropping down. And now here go my parentheses, dropping those x's in. And when I go for 4, I have to realize that 1 and 4 can make 4, or 2 and 2. And the choice I want is not 1 and 4, because I'm trying to get these side numbers. And while 1 can make both of those, 4 can't make either. So that leaves this out. But this 2 can make 10, and this 2 can make that 2. So I'll drop 2's in here. And now I'll let this 2x times a positive 5 make 10x, and this 2x times a positive 1 make 2x. So again, I'm going to set this factor equal to 0. I'm going to set this factor equal to 0. And I won't bother with this one because this factor does not have an x in it. I only worry about the factors with an x. So I'm going to subtract 1 here, which gives me negative 1, and then I'm going to divide by 2, and that gives me negative 1/2 as one of my 2 answers. And on this one, I'll subtract 5 over, so that gives me a negative 5, and then I'll divide by 2, so my second answer is negative 5/2. Last problem that I want to show you is, again, it is in standard form. It does equal 0, so I'm going to go for my GCF. I'm going to take a 2 out. So I'll be left with x squared, and then from here I'll have minus 3x, and from here I'll have minus 5. So now when I make my x, it'll be based on this. I need factors of negative 5 that get me to negative 3. So what you're going to notice that the only factors of 5 are 1 and 5, and there is no way that 1 and 5 can make a negative 3 or even a positive 3. So this is what we're going to call not factorable. So we did factor as much as we could. We took a GCF out, but because I'm not able to get this into factored form, and factored form is an x plus a number. Maybe it's 2x plus a number, or maybe it's just x plus a number, but I won't be able to solve for this one. There is a way to solve, but we have not covered that one yet. So it's just the idea of this problem is just to introduce you to the idea that not everything is going to be factorable. So we'll be coming up with a backup plan. And that's it.